Hey guys, what's up? It's Panda Power for a new video. And today I would like to talk about Yuzu Prometheus, Switch emulator working pretty well on different platforms like PC and Linux, and which is the more known emulator for Switch. The other one is Ryujinx. I just wanted to mention its name because I won't cover it in this video and will focus only on Yuzu. As a definition, Yuzu is an experimental open source emulator for Nintendo Switch from the creators of Citra, well-known 3DS emulator. It is written in C++ with portability in mind, with builds actively maintained for Windows and Linux. In this video, I will show you the progress made by Yuzu in the last year, the evolution of the emulator, and the recent big improvement with Multicore support. As a side note, I will show you some games running with this emulator as an example of what it's capable to do. But I won't show you any setup here, as I consider that emulation should stay an experiment because it's always great to do experimentations, especially if you are curious as I am. But emulation actually leads to download illegally games and not pay any money to game creators and Nintendo at the end. So I encourage you seriously to buy a Switch console and to get the real gameplay experience of the Switch and the great feeling it provides. However, the emulators are great and useful because they're testimonies of the past, meaning that when any console is getting old and you are not able to buy them, or any rated games like Genesis or SNES for instance, it remains possible to play these consoles even if they were released 20 years ago, which is really awesome. And now it's said, let's jump into our main topic. Okay, first let me show you some examples of gameplay you can achieve with Yuzu so far.
Hello. No como Mario.
As you can see, some games like Zelda Breath of the Wild or Mario Odyssey can be run easily with this kind of emulator. Okay, I will let you watch this. In the meanwhile, I will provide you some fundamental explanations on the name. Yuzu means citrus junus and is a citrus fruit and plant in the family Rutaceae. Sorry for the pronunciation. It is believed to have originated in central China as an hybrid of Mandarin orange and the Aicheng papeda. Sorry again for the pronunciation. As a side note, the yuzu is called yuja in Korean cuisine. In Greek mythology, Prometheus is a titan that aided humanity to teaching how to make fire. In modern society, it symbolizes the strive for scientist knowledge. The Prometheus project is about that, the journey to new emulation techniques, and well, I will explain all that stuff to you in a second. And so you will see it makes totally sense. Now just have a look on how beautiful the game is and how smoothly it's running. It's really amazing. We've got constant FPS on major games, even on i7, i5, and some Ryzen 5 and 7 too. Even if games are running well on these CPUs, I truly recommend you an i9 9900K or KF. As a side note, it's the same CPU. The only difference is that the KF doesn't have an integrated video card. But who is using the integrated video card today on this kind of expensive hardware? Usually it's not the case. That's why I recommend you the KF, which is usually $40 to $50 less than the K. Now, why an i9 9900 KF, you will ask? Actually, the i9 9900 KF has 8 cores instead of 12 for the Ryzen 9 3900X. You will ask me, why not using a CPU with the bigger number of cores for a multi-core software like Yuzu? And well, your question is very good, and I thought for a very long time that the high number of cores will be the answer to all my performance problems. But actually, it's not so simple. Let me explain this. Both CPUs got idle frequencies, respectively 3.6 GHz for the i9 9900KF and 3.8 GHz for the Ryzen 9 3900X. What is impressive in both cases is that these CPUs, when under pressure with highly demanding tasks like rendering or calculations, including playing video games, are able to boost their cores. On the Ryzen 9 3900X, the boost means all 12 cores are going from 3.8 GHz to 4.3 GHz, which is really great as we see on this picture here. On the i9 9900K or KF, as a comparison, we can see that the boost is higher on the first two cores, going from 3.6 GHz to 5 GHz, and is 400 MHz more on the other cores than the Ryzen 9 3900X. So at the end, using an i9 9900KF is still more efficient for gaming, especially with the number of cores Yuzu is using, as we will see later in this video. As I told you, look at this smooth emulation, but it hasn't been always the case before. And look at what was the emulation with Yuzu before. All of those gameplays ran on i9 9900K in the past with old version of Yuzu. And as you can see, well, it's not what we could call smooth or playable. Depending on the game you wanted to play, it was simply impossible even with a 720p resolution. Let's try to explain why. Yuzu is considered as a HLE, High Level Emulation Emulator. This means that instead of running the real Switch OS known as Horizon, Yuzu has recreated its own version of the OS, built entirely from the ground up. Like your PC, the Switch has multiple cores, four actually, and the Horizon OS can run multiple tasks in parallel on these cores using a kernel construct known as a thread. However, due to the limitations of the old kernel design taken from Citra, Yuzu was actually emulating this behavior using a single core on your host PC. This had led to high CPU requirements for end users. With the recent multicore CPU emulation, instead of emulating the CPU on a single thread, Yuzu will now emulate the CPU using multiple threads. Four exactly, one for each Switch CPU core. Yuzu's initial CPU emulation in kernel were heavily based on Citra's. The kernel emulated the external behavior of the Switch's kernel, but vastly differed from the Switch OS. Instead of saving context and switching from one guest thread to another within the kernel, it was using a mechanism within Citra's kernel that emulated the same behavior but with a complex system of stops and callbacks. Not only that, Yuzu used something called a cycle timer. A cycle timer is a mechanism to emulate time on consoles by counting each guest instruction executed and added it to a global CPU ticks. These ticks can then be transformed into time units, like nanoseconds, by using the guest CPU frequency. We can see that Citra's model was perfectly fine for single-core emulation, but in the case of Yuzu, it wasn't really efficient, let's say. The Switch is a much more complicated and modern system that pushes four CPU cores, where three are used for apps games. Not only that, but the scheduling is more robust and can be used in some more interesting and more complicated ways. The code didn't match the Switch OS, and even though it had the same behavior, it was hard to keep track of changes and replicate them. The code was very complex, and there was a callback for everything and was hard to maintain. And here comes Prometheus. Prometheus is the internal code name for this feature's development, and it is a total rework of these three things. First, you have the kernel scheduling. Second, you have the boot management. And the last, but not least, CPU management. Prometheus aims to ensure that emulation behaves the same as on the Switch while matching the code with the Switch's original OS code. And as a byproduct, host multicore support using hosts timing has been added to Yuzu. Host timing is just Yuzu using the host's internal clock for timing. The multicore feature of Prometheus is the beast in terms of thread handling. Originally, Yuzu used at best two threads, one for the CPU and one for the emulated GPU. With multicore, there are now six threads in use, four for the CPU, one for the timer, and one for the emulated GPU. Development team working actively on Yuzu Prometheus encountered multiple challenges and considerations for development. I would like to mention that Ryojinx was using multicores already nearly since the beginning because instead of using their own kernel, they are using the official one from Nintendo Switch, Horizon, meaning each time you want to get new games working with it, you have to update it on your own. Yuzu doesn't have this issue, but they went the hard way because they've got to update the kernel each time Horizon is updated to integrate bug fixes or new features in the kernel. After fixing a bunch of issues with JIT, just in time compiler, and mutex corruption, leading to exclusive memory handling in ARM v8 and multicore issues, they were able to run some games like Luigi's Mansion 3, Hyrule Warriors, and Super Mario Odyssey. which is great. Another interesting challenge for the Yuzu development team was to implement pausing resuming in Multicore. The feature was already available, so we could pause and resume Yuzu in current versions. This was simple before because emulation occurs in steps, and we just had to stop on the next step. But on multi-core, emulation is continuous and unmanaged in the same sense. So they had to create a kernel thread for each core and make that kernel thread pass control from and to the CPU manager to the emulation to solve this problem. I know what you think. Multicore support is so great. It is like playing on a Switch, right? Well, it's not so simple. Actually, not every games are using multi-threading effectively and makes the most use of the Switch's CPU. Some games like Super Mario Odyssey barely use cores 1 and 2 by doing all processing in core 0, so the first core, effectively not making gain nothing from the multi-core. However, games like Breath of the Wild see some performance boost but are still bottlenecked by the emulated GPU. So now let's have a look at the emulated GPU, which is mainly used, as you can guess, for 3D processing. It mainly relies on four things. First, your CPU's single core speed. Because a single core CPU core is used to translate all the commands from guest GPU switch into host's GPU user commands. That's why having a CPU with a high single core speed is most beneficial. Second, your GPU bus speed, because Yuzu heavily relies on the bandwidth available in the GPU bus. This is the speed at which data is uploaded to and from your GPU, and this varies depending on PCI Express generation and allocated lanes. Third, the quality of your GPU drivers. Unfortunately, AMD's drivers for OpenGL are not really great, while NVIDIA's are top-notch. This one is a little less important because you can use Vulkan framework now, but still it's important to know that fact. Fourth, your host GPU itself, be it NVIDIA, AMD, or Intel. Finally, amount of RAM and the type of processor in your system will also greatly influence your gaming experience. From the beginning, the Yuzu development team spent a lot of effort on trying to fix additional memory usage of the software. Concerning that specific point, let's talk about this memory improvement. Also, recently, the Yuzu team did great improvements on memory usage. With regards to memory usage, it was not uncommon for Yuzu to eat up to 8 gigabytes, 16 gigabytes, or even more RAM. So the development team decided to rewrite all of Yuzu's memory management code, and they released a new version at the beginning of April that was on average using 50% less RAM. Here you can see the before and after memory usage for several popular titles, measuring while in game, and as you can see, the memory usage optimizations are insane. To achieve that, they wrote from the ground the Yuzu's Virtual Memory Manager, the piece of software components that allocates, maps, and frees memory that Switch games use. This is a part of the emulator that uses high-level emulation, as I was telling you, HLE, to replicate functionality of the Switch's Horizon operating system. Previously, Yuzu used a rather simplified approach to the VMM based on Citra 3DS emulator. In short, this old implementation coming from Citra arbitrarily was allocating and mapping host your PC memory on the fly without respecting the guest Nintendo Switch memory layout. This resulted in runaway host memory allocations that were never actually possible on a real Switch. Here is a more comprehensive before and after memory comparison for many popular Switch games in Yuzu. As a result, emulation should in general not exceed switches 4 gigabytes of dedicated RAM, with the expectation of some games that eat memory for other purposes. For example, GPU, audio, and OS emulation may still push the emulator beyond this. That being said, you may now expect the games to use 2, 4 gigabytes of RAM maximum and on average, rather than double that. To sum up, Yuzu did great improvements in a very short amount of time, and hats off to the Yuzu team that works very hard to bring Switch emulation to PC. The emulator is not perfect though. And also, I think you could have a look at the competition, Ryojinx, for instance. That is working not so bad too. Even if it's not working exactly the same way, it's becoming more and more popular among players. And that's it. Hope you enjoyed this video. What I encourage you to do is to go on YouTube. I guess if you're watching this video, you're already there, right? And look for recent uploads concerning Yuzu. So just write Yuzu in the search bar at the top and sort by upload dates. You will see different videos of different players' gameplays showing how it runs. Then, with their specification in the descriptions, you will be able to size if it will run smoothly on your PC or not. Also, Yuzu has got a Patreon page, and I think it could be very great to subscribe to show your support to this wonderful project. As usual, if not already done, subscribe to my channel. I've got much more stuff coming and you will like it for sure. Thank you.